Howdy y'all, Mr. Campbell House here. Today I'm going to show you how to add a circuit to your service panel. Got my dog Junie here and she's being a little feisty. Today I'm going to show you how to add a receptacle and circuit to your service panel. Right here I've got a service panel in my garage. This runs to my maid feeder panel. I installed this last year to do an electric vehicle supply that's on the other side of this wall. So we're going to go ahead and get started. We're going to start by shutting off the breaker to the sub panel. So it's this 60 amp guy right here. So we're going to go back to the sub panel now. Okay, so now that we've shut off the breaker that feeds the sub panel, we're going to go ahead and open it up. We've got a number 2 square drive, so we're going to go ahead and use that to open up the panel. Set those fasteners up here. We're going to be careful not to touch any of the bus bars or electrical components. And the first thing we're going to do is we're going to use this non-contact voltage detector and make sure that there's no power. So you can see we're testing all of these and we're good. And it's always a good idea to check one of these on a known powered surface. So we're going to go ahead and check this one right here. So as you can see, when I check this against a known line surface, it is detecting power. Okay, we're going to start by hammering out one of these knockouts. I like to try to put in some hearing protection when I'm doing this. I've got in my AirPods, just because obviously banging around in these metal boxes can be pretty loud. Let's see what we got here. We'll try to hammer this out from the bottom. All right, so we got our knockout loose. So the next step is we're going to see if our fitting will fit in there, and I think we're going to have to step it out just a little bit. Let's see here. So I've got a 3/4 inch fitting. So we need to bump that out a little bit. We could have used one of these bigger knockouts, but they're further from the wall. And the offset fitting I've got doesn't have enough length to get us to the wall. So I'm going to use a stepper bit to widen that hole out just enough to let us get in there. Okay, so we're going to go ahead and we're going to start by putting on our offset 3/4 inch conduit fitting. And then what you can do with this collar right here, you're supposed to take like a flathead screwdriver or a punch, and you can hammer that on to get it good and tight. All right, so we got that nice and secure. All right, so now it's time to go ahead and find the location for our box. So what I'm going to do is I'm going to set up a straight line from our piece of conduit. And what we're going to do is we're going to line up our receptacle below it. Where possible, I highly recommend that you try to find a stud to secure to. Unfortunately, since we're lining up off of this knockout, we don't have that option. So I'm going to use 4 of these heavy drywall anchors. If you're doing something that has a lot of insertion force or pull-up force, like this 1450 receptacle, I highly recommend you find a stud. Something I forgot to do beforehand is to measure the insertion depth of our fittings. So before you mount those to a place where you can't get your conduit into, go ahead and check that. So take your loose fitting, drop it on, and mark it with a Sharpie. And what we're going to do is we're going to measure that later and add that to our cut length. So what I'm going to do is I'm going to go ahead and attach this to the wall loosely, just so that I can measure the length of my cut for my conduit. So what I'm going to do is I'm going to take my tape measure. I'm going to measure, that is roughly 18 1/4 inches from this fitting to this one. And then I have to add the insertion depth on top of that. So we're going to go ahead and we're going to cut. Put this thing to reverse so it's throwing sparks towards you, not towards me. And we'll go ahead and get started. Now I'm just going to go ahead and I'm going to clean up the edge of this cut. All right, we're going to go ahead and we're going to clean up the ID of that with a stepper drill. A file is better. I don't have a file handy, so I'm going to use my stepper drill. Now that we've got our conduit cut, I'm going to go ahead and pull the screws that are holding it into the wall. Okay, so now we're ready to pull our cable through. I'm using a piece of 12-2. So that's 12 gauge with 2 conductors. You don't count the ground. So that's a black, a white, and a copper. We're going to go ahead. I'm going to show you how to pull it. What the method I'm going to use is entirely overkill for this short pull with no bends, but your pull may be a little bit more difficult. So I'm going to show you how to do that. Okay, so now I'm going to go ahead and I'm going to prepare the end of this cable. For the neutral and the ground, of course, as much of those can be exposed as we want, but the live, the black, we want to try to keep that to the minimum amount necessary. This one says 36 inch-pounds of torque. So I'm going to come back and I'm going to torque that in just a little bit to 36 inch-pounds of torque. But for now, we'll continue on. So we've got this secured in here. So what we do is we hinge this in, push it until it pops. This is a square D breaker. Yours might be a little different, but we're pushing it until it pops here and then levering it in like that. And that breaker is secured in place. Now for our neutral, we can use any of these neutrals available up here. This is a sub panel, so our neutrals and grounds have to be separate. So as a result, we have way more spots than we need because this panel was configured out of the box to share the grounds and neutrals on one bus. But I went ahead and got the separate ground bus kit for it because I was using it as a sub panel. So I'm going to go ahead and we're going to take our ground and I'm actually going to trim a little bit of this ground off and we'll actually reuse this in just a minute. Okay, so I'm going to go ahead and get my torque driver and we're going to chase these and make sure everything's tight and then we'll proceed with the next step. Being that this is in a garage, I've got to use a GFCI, a ground fault circuit interrupter, and I've got to make sure that I put my power into the line side and not the load side. If you put it into the load side, it will not protect the circuit. The nice thing is I only need to use one ground fault circuit interrupter for both of these receptacles because I'm going to put the second receptacle onto the load side, so it's piggybacking off of the protection that this GFCI produces. Okay, so I went ahead and wired up the second receptacle. That second one does not have, it's just got a normal screw terminal, so make sure you make a hook so that your wire can seat more securely. So, and then we're going to go ahead and we're going to hook that up to the load side of our GFCI. So, loosening these screws and then retightening them once I've got the wire through. I went ahead and changed from a 3-way Wago to a 5-way so that I could get the ground on here a little easier. Make sure not to pinch the insulation in your breaker or your receptacle because it can create a high resistance connection which can create heat and potentially even a fire. All right, so we've got both of these receptacles wired up. So now it's my least favorite part, which is trying to wedge all this stuff back in the box. We want to make sure nothing is pinched and that there's not any, that the ground is not touching the neutral or the hot terminals on either of these plugs. I've seen people electrical tape over their plugs and switches before, or receptacles before putting them back into the box. I think it's a little overkill, but not the worst idea in the world either. So typically you feel like you're kind of manhandling this stuff, and you kind of are, but that's just how it goes. The one thing you just want to make sure is when you're starting the screw, make sure that it's not cross-threaded, and make sure that you're pushing pretty hard until you get full engagement. What you don't want to do is strip the threads because it's being pushed out too hard and you don't have good engagement. Well, unfortunately, I thought I had plate covers at the house, and I have a ton. I have single gang and 3-gang, but no 2-gang, so I don't have a cover to put on here for you. I really like the screwless type because they're a lot easier to adjust. So I would recommend getting the screwless type if you can. When you're getting these lined up, something I like to do is put a receptacle tester in so that you can hold the plug in while you tighten it down. In fact, let me go show you how to do that. So you can plug a receptacle tester in here, and that just gives you something to pull against, either side while you're tightening this screw. So I can use it to pull left or right, or even to kind of torque the face a little bit when I'm putting these in. So you want to try to get them square. So now that we've got that done, we're going to go ahead and tighten everything up and close the box up. So imagine this has got a receptacle cover on it. I know we don't right now, but just pretend it. All right, so it's time to tidy our box back up. So we're going to go ahead and push these wires back to where they were when we opened this to the side to make sure we get the cover on. I'm going to take our cover, open it up, and slip it on just like that. So now we're going to go ahead and we're going to turn the breaker back on, and then we'll come back here and test it out. Oh, and make sure your breakers don't get jammed. See how we've got one stuck right there? So we're going to loosen this up. I don't know if you can tell that one's caught a little bit. So loosen the cover. There we go. That pops up. So make sure that everything's lined up and nothing's pinched. So we're going to go ahead and we're going to flip this 60 back on. All right, so I'm going to turn the breakers back on. So this is the one for my external Tesla charger. This is the one for my internal 1450R. And then this is the new ones we just put on down here. So we're going to go ahead, we're going to reset this GFCI. It's green, that's good. And we're going to use this circuit tester to make sure it's wired correctly. Again, pretend it's got a cover on it. So we're getting 121 volts. It says correct. We're going to test it. It did trip. Perfect. So we're going to have to go ahead and reset this. All right, push to reset. Now we're going to check this one. 121 volts, correct. And again, this outlet is not a GFCI, but it's connected to one. So when I hit this test button, this one should trip. And it does. So again, I'm going to show you that tripping one more time so you'll see. When I press this button, you're actually going to see that reset button pop out. So this is all working correctly. If this had the cover on it, this would be fully done and ready for use. I almost forgot, your conduit has to be attached within 3 feet of the box and every 10 feet. So even though we've got small pieces here, we need to go ahead and have straps. So just went ahead and added those done. So we are officially done minus this cover. Thanks for watching. In my next video, I'm going to show you how to install a generator inlet and interlock for about $100 so that you can run your entire home off your generator or power station during an outage. so make sure you're subscribed if you want to see that. As always, if you have any questions or feedback, make sure to leave it in the comments below. This has been Mr. Campbell House. Thanks for watching.